Well, hello everyone. My name's Gavin Lewis, and I'd like to welcome you today to our joint webinar with Fathom and Jacobs to talk about their flood modeler platform and our data. So, if we go to the next slide, um, I'm head of engineering here at Fathom, and I've been with the business for some 6 years now. And I'm joined today by Cristina Agafon. Cristina, would you like to just introduce yourself?
Thank you, Gavin. So, as Gavin said, my name is Cristina. I am currently the customer success lead for flood products in Jacobs. I am also an experienced hydraulic modeler and hydrologist with almost 10 years within Jacobs. And today I'm here to support Fathom and present the Fathom tool within Flood Modeler, the current version and the future version.
Great, thank you. So, what are we going to cover today? We've got a pretty busy agenda. I'm going to start off and give you a bit of a flavour about Fathom. You might not have come across us before. You probably know Jacobs and their great flood modeler platform, but may not know a bit about us. So, I'm going to give you a bit of a context, talk about what our data looks like, and why it's different. Well, I'm then going to hand over to Cristina. So she's going to do a live demo talking you through a really good case study using our data. And then at the end, we're going to have time for questions and answers. So can I ask you, please, a bit of housekeeping that we do really keen to get your questions, but please use the Q&A button at the bottom of your screen. Just click on that. A panel will open up and you just need to type in your question to that, and we'll pick that up at the end. So hopefully we'll have about 5-10 minutes to pick up on any of your questions. Okay, let's get into the presentation. So what does Fathom do? Well, we're effectively a business based here in Bristol that build flood models. We build models that represent the behaviour of water flowing across the Earth's surface. Everything we do is underpinned by very robust scientific research. The business came out of Bristol University, and so everything we do is all our methodologies and validation of our data sets is we publish in our papers, and those are published in the leading scientific journals. We make all those papers available on our website, and this kind of gives you a bit of a timeline of the papers that we've been publishing. So if you are interested in understanding more about our methodologies and want to dive into some more details, then I would recommend going to our website, looking at the knowledge page, and then you can see all our papers there. Failing that, please come back to me if you've got any particular questions around that. You'll see my email at the end. Next slide, please. So we develop a framework for developing flood-related data sets. So what do we actually produce? So we produce flood maps, both for here in the UK and globally. We've taken those flood maps and have created risk scores to allow organisations to very quickly categorise assets or portfolios of assets for flood risk. And that's a risk categorization, but also calculating a relative risk in financial terms. We also have global terrain data. Now, of course, we modeling flooding, flow of water. We need to know where downhill is. So essentially, when we first started developing our models some 10 years ago, we had to make do with what was out there. And that was the old SRTM data, which is very old and quite a lot of holes in it. And people that have used it probably know that. So we decided to do our own thing. And on the back of that, we've developed a series of terrain data sets that underpin our models, but we also provide them separately. And I'll talk a little bit about that in a minute. And then we've been talking about hazard and risk through the flood maps and the risk scores, but also we're able to develop and provide information around calculation of financial losses due to flooding. So we've taken our data sets and developed catastrophe models, and those are used very much in the insurance industry with our insurance clients to basically underpin their operations around underwriting and pricing for risks both here in the UK, Europe, US, and globally. So we're able to calculate losses from our cat models. Next slide, please. So from our flood maps, we have a series of detailed flood maps. Essentially, we have detailed data sets for the UK, the US, and Japan, and those are at 10-meter resolution. And then we have our global data set, and it is truly global at 30-meter resolution. Okay, so we have a series of data sets that we provide to our clients, and ultimately which are available in within Flood Model. So if we go to the next slide, what we do is we model both pluvial, fluvial, and coastal subperils separately. And for the fluvial data set, we basically take into consideration the flow in the river channel. So we use full 2D methodology to manage and capture our flows, and also in-channel flow, but obviously when we get overtopping into the floodplain. So on the pluvial data set, which is the next slide, we model a rain-on grid type scenario where we're capturing short duration events for flash flooding, and also we're capturing those smaller channels that the water percolates into. So we're able to model them quite differently, and we're also then model coastal flooding, where we're looking at a different mechanism there. Next slide, please, where we're looking at a different mechanism, or looking at overtopping of the coastal defences. So all those three data separate subperils that you can see, we provide in a defended view and an undefended view. So you can compare the two and understand the impact of the defences we've modelled into our data. Next slide, please. So what I've shown you is very much around a current snapshot, but of course we're in non-stationary times in relation to climate. So we've been done a lot of work in developing a framework to allow us to get a much better understanding of the impact of flooding, not just today, but what's that going to look like by the end of the century. Next slide, please. So we have developed what we call the climate dynamics framework, and that allows us to provide a future view of flooding under any time horizon between now and 2100 for any recognized emission scenario or change in temperature. And that gives great flexibility with our client base that want different epochs of understanding of flood risk under different emission scenarios. So we provide that data, and that data again is available through Flood Modeler. Next slide, please. So I've talked briefly about the flood maps. We've taken those data sets and developed a series of risk scores, and that allows you to very quickly categorize those assets and profile those assets in relation to risk, and then triage them to identify the assets that are potentially most risk or most exposed to flooding. This is a very useful data set when you're looking at many assets in one area, or perhaps on a global scale, to compare them and contrast them to identify those that perhaps need further investigation in relation to flood risk and exposure, mitigation and adaptation. Next slide, please. So in addition to the flood maps and the risk scores, we also provide an additional data set, and we call that our metadata data set. And the important thing around that is it gives essentially an uncertainty rank, because we pull data from a whole range of different sources and we develop that at a local and a global scale. A lot of our clients have asked us to say, okay, well, we need to understand, the data that you've built from. What terrain data have you used? Is it really good LiDAR, or have you got to rely on other data sets? So we pulled that together and as part of the metadata layer, and this is an additional view to help you in your decision-making process when you're looking at the outputs from the maps to say, okay, what's the certainty rank aligning with that to help give you confidence in making decisions and recommendations about the data. Next slide, please. So I talked about the global terrain data set. we have developed a data set called Fathom. It covers, as I said, globally. And if you wouldn't mind just going back a slide, please.
Sorry. Yeah.
Thanks. No worries. So that's a global data set. And of course, we pull in any open source LiDAR that is available. So that's the darker color on the screen there. And you can see across Europe and North America, Australia and New Zealand and Japan, we've captured all the open source LiDAR. We've built that into our data set. So we can provide these data sets that are a combination of LiDAR where we have it, but where we don't, we backfill with our FabDem data set, which is essentially a 30-meter resolution global data set. So we've used that to underpin our flood modeling. But as part of the work that we've done around pushing the scientific boundaries, if we go to the next slide, we've now developed a new data set called Fathom. And if you can look at the panels below, on the left-hand side, we've got the LiDAR data. And of course, that's really the gold standard for any data, the terrain data that we want to use for flood modeling. And you can see there that the core COPDEM data that a number of people use, our current FabDem data, and then the new data set that we've developed called FathomDem. So we've used a series of machine learning technologies to actually improve that. And if you compare the image on the LiDAR to the FathomDem, you can see there's a very good representation and comparison between the two. So this new data set is available through the Jacobs Flood Modeler, and it's got global coverage, and we're now going to be using that for our next generation of flood models. And it's really another step forward in our understanding of terrain data and modeling. Next slide, please. So this just gives you a very quick overview of how we benchmark our data against a variety of data sets. So in the US, against the Iowa Flood Center, FEMA, and then importantly here in the UK, how does our data compare to the LiDAR that the Environment Agency produces? So you can see that looking at this particular critical success index score, that we benchmark very well against those data sets. So this is going to be, as I say, a real step change in our to help us produce much better models using the better terrain data that we have developed. Next slide, please. So, why use our data both today and for future climate scenarios? Well, I think it's important to recognize that although we provide the data sets, we're very keen to benchmark and validate our data sets against known entities and other data sets that are out that people are using. And of course, in the UK, that's the Environment Agency. Obviously, if you're working in England, Natural Resources Wales or SEPA in Scotland. So we've benchmarked our data against known entities, and we publish those scores in our papers. It's not just the UK. We've done a lot of assessment of our data across the US and at a global scale. And it's not just validating against other flood data sets. We also bring in observed events and benchmark our prediction or projection of those events against what's actually happened on the ground. And again, we have a good correlation. So what essentially does that look like? If we go to the next slide. Many of you will probably recognize this as Carlisle, and unfortunately there's been a lot of flooding events in Carlisle over the last sort of, going back for many years. So as a consequence, it's very well mapped, it's very well measured, and a lot of the events are captured. So it's a great place to benchmark our data. So we've run a number of simulations and models against observed and benchmarked data, and effectively, our data behaves within mean error of the observed observations, and that tells us that we are getting very close to the actual representation of those flooding events that are happening on the ground, and that's a great validation for our data going forward. So if we go to how does our data compare against the Environment Agency data, and of course a lot of you use that, and you have to use that for various statutory and requirements and projects, but our data covers not just obviously England, but Wales and Scotland. And so if you're looking at projects that are across all three countries, then you want a consistent view of flood risk rather than three different data sets. So that's where we bring, and we compare our data to EA, and it compares very favourably, both under current climate conditions, but also moving forward. And of course, the EA data is changing with NAFRA 2 coming out. And again, our data is evolving and keeping in step with our science and development in projection to that. Next slide, please. So you've got a bit of a flavour about what our data looks like and how it compares and what it covers. I think the important thing here is to say, okay, where can you actually apply Fathom data? We sit very much invariably at that early stage of a lot of projects where you're saying, okay, we've got this area we need to analyze, or we've got specific sites we need to identify and validate and compare against each other. It could be looking at critical infrastructure, or a really expanding use case is linear assets, road, rail lines, communications, infrastructure, where you have various nodes and points on a network, and you really need to understand and get that initial overview to say, okay, where are the areas of problems that have been identified by the Fathom data, where flooding is impacting that infrastructure, and then allowing you then to do a deeper dive and use platforms like Flood Modeler to actually do a much more detailed flood model. But what Fathom data does is effectively signpost you there. It helps you get and identify those problem areas very quickly. And that could be looking at just purely flooding, but also using our future views around climate resilience and adaptation projects for infrastructure and assets. Okay. Next slide, I believe, is a poll. So we've got a couple of questions we'd like you to answer, if you wouldn't mind just responding. Just to understand, essentially, which areas do you work with? What the projects you're involved in, do they cover just the UK, Europe, North America, or LATAM or Asia? And then also just getting a sense really from which Fathom data sets do you think you might be interested in or potentially used as part of your projects going forward. So we're just getting a sense of that. If I can ask you to vote, that'd be great. And whilst you're making your selection there, I'm going to be handing over to Cristina now after this poll, and she'll then be able to take you through a live case study using our data.
Thank you, Gavin. So the Fathom's flood data is both extensive and versatile. So it's offering very high resolution insights that support initial assessments across a wide range of geographic locations, including international applications, as you have seen and Gavin has mentioned. Its integration of fluvial, pluvial, and coastal hazard modeling combined with different climate scenarios projections and detailed terrain data makes it quite a powerful tool for both strategic planning and detailed analysis. And in the flood modeler segment of this webinar, we explored an alternative application of Fathom data, which is beyond the traditional approach of river flooding and residential property risk. And given the proximity of both the Fathom and flood modeler teams to Bristol, we focused on a major infrastructure development in the region, which is the Hinkley connection project. So you can see on the slide, I have a screenshot of the area. So we see Portishead, we see Bristol Port, and with the red polyline, we see the overhead line. And the small triangles, the points are actually the new pylons that have been installed. This project involves a 57-kilometer high voltage overhead line, which is connecting low carbon energy from the Hinkley Point C, so at the north of the map, which is a nuclear power station, and the renewable sources in the southwest, the UK electricity grid. And this route spans from Bridgewater to Avonmouth, and it's passing through Somerset and North Somerset. And notably, the project features the UK's first use of T-pylons, which are a modern and compact design with a reduced visual and physical footprint compared to the traditional lattice pylons. And one section of the OHL crosses the River Avon near the port, presenting an opportunity to assess flood hazards in the area. So using the Fathom's 10 meters resolution data, we examined fluvial, pluvial, and coastal flood risk under various climate scenarios. And we've also constructed a simplified 2D hydraulic model using the Fathom terrain data. And we have some tidal inputs to evaluate some flow velocities around the installed pylons. And first, after we have identified the objective of the project, so in our case, we want to assess the flood risk from all sources. We will be mainly focused during this webinar on the coastal one. We will identify the data gaps that may affect safety evaluations. We will move to gather the data. So we'll be looking at the Fathom UK flood data, which covers fluvial, pluvial, and coastal flooding. They use a high resolution, so it's approximately 10 meters hazard layers, and different climate scenarios for 2030s, 2050s, and 2100. For the terrain data, we will be looking at the FAB DEM Plus. We can also request some EA LiDAR data for elevation. Then for the existing flood maps, so again, we are trying to gather as much data as we might need for this assessment. We'll be looking at the flood maps as well, which are the EA flood zones and long-term risk maps, which are less detailed than the Fathom data. And we will also be checking the local alerts for Clevedon and Somerset Coast. For the infrastructure data, you might want to collect the tower locations and the route from the national grid and planning documents. And using the collected data, you start the gaps identification process where you might find that there are some resolution issues in the EA maps. There are some uncertainty in the flood defenses and their representation. You might have some missing hydraulic connectivity. So if you have some small channels that might not have been properly represented, compound coastal flooding not fully captured. You have some infrastructure interaction with flood pathways, which might need a better integration. And then you might decide that you actually do need a bit more detailed, and you plan on building a hydraulic model in Flood Modeler. So you might want to have a 1D, 2D model setup. So in 1D, you could integrate the rivers and the culverts. And the 2D, you'll be looking at the floodplains, urban coastal zones. For the data integration, you will want to import some Fathom hazard layers and the FabDem plus terrain data. For the calibration and validation of your model, you will be wanting to compare the model results with historical floods and EA records. And you can also use Hydrology Plus for observed data extraction. For the risk analysis, you could look at the Fathom data and the model results and do a tower level screening. So you can overlay the tower locations on flood maps, assess the risk under multiple return periods. So for example, you have the 1 in 100, 1 in 1,000, 1 in 5, why not? You can flag towers which are located in high risk zones. So just for example, if the water depth is greater than half a meter, you might have towers which are located in uncertain zones, so where you have some data gaps, or some defended zones, so you will have to check the defense reliability. You want to do some scenario testing, so you compare present day versus future climate, and then again, you have the Fathom data that you can look at. And you might want to have some scenarios with and without flood defenses. And to tie everything together, you prepare a report to summarize the findings and draw a list of recommendations. So you present the outputs, the maps of the flood extents, the velocity, and the risk matrix, tower location versus flood risk. And you could also add some recommendations for future work, which could be to relocate or elevate towers in high risk zones, conduct further surveys in data sparse areas, and account for some compound coastal flooding as well. So now for the live demo, I will first show you a sneak peek into Flood Modeler 8.0. And for more information on release date, how to download the latest software version and the release notes, please visit the Flood Modeler website and the knowledge base. Okay, so this is our still in development version 8.0. So when you will open the software, it will open straight into the Home tab. And we have moved now the Fathom tool within the Home tab, so it's easier to access it. I have added the base map and the OHL and the tower so that we can see where they are located in our area of interest. We can download Fathom data, view existing Fathom data, and we have also added a shortcut to the general settings. If I open the general settings, it will take me straight to the Fathom settings where you will need to add a client ID and a client secret. In order to get these details, please contact the Fathom team and they will guide you through the process of getting a license agreement. So if you want to download Fathom data, you can choose from different categories. So we have the global terrain data, that 30 meters, or the 10 meters FabDM Plus. You have to add a project ID. You have to select the output folder, and if you want, you can add a suffix and then retrieve the data sets. Just make sure that your units are under 250. We then have the global flood map 3, where we have flood depths and risk scores, which we can download. And we can have data files for different return periods, for different types of flood maps. We will have the depth, which we will download. We have only the 2020 scenario. We have the UK flood map 1, where again we can download the flood depths, but in this case we have different scenarios. So we have the 2030s, 2050s, and 2070s scenarios. We have the US flood map 3, where we can download flood maps, water surface elevation and risk scores, again for different return periods and types of flooding sources. And this is just testing for our development team. So for our modeling exercise, I will switch to Flood Modeler 7.3, where I have already loaded the files which I will need for this assessment. The Fathom tool to download the datasets in Flood Modeler 7.3 is actually located under Results, Fathom Data. In order to add here the client ID and secret, you have to go into the settings. So under Home, General, Default Settings, and we have here the Fathom settings. You'll need to add here the details in order to access and download the Fathom data. And the tool is quite similar with what I've showed you in 8.0, with the exception that in 8.0 we have more data sets which we can download from Fathom. So on our map, we can see Avon Mouth. So this is the area that we are interested in. I will now add the Hinkley Powerline JS data. So I have here the towers and the overhead line. So these have been already installed. We can also add the AIMS data. So I'm specifically looking at the spatial flood defenses dataset. And I can see that there are a few defenses in the area. So there are defenses in the estuary on the left bank and right bank of River Avon. And we will then add, or I will actually plot the Fathom data for the initial assessment. So I will be looking at the terrain data, which I have downloaded. And we need to do an initial assessment. Do we have FabDM terrain data covering our area of interest? Then if I will add the risk category, does the risk category file for 2020 shows us that there is any risk in the area where the T-pylons have been installed? And we can see in here that at least one pylon is located in a risk area. So if I will do a quick check to see what the risk of this pylon is. So I'm looking for the flood map coastal risk. I see that I have a risk of 56 out of 100. So you can view different information of the layers which you have loaded. I can also add the hazard maps from Fathom. So I have here different layers which I have downloaded, but we will mainly be looking at the coastal results. So I have the flood maps for 1 in 5. We can see that the pylons are not at risk of flooding. 1 in 100, which also looks quite well. Then we have 1 in 1,000, where at least one pylon seems to be at risk of flooding. So, okay, 1 in 1,000, it's not an event that will occur quite often, does it? Maybe, as it says, the 1 in 1,000 years. With climate change, it can happen a bit more often. But we want to know what will happen if there is a breach in the embankment. So for this case, I have built a quick 2D model where I looked at what how the tidal will influence the risk, how the tidal will add a risk to the already installed pylons if there is an embankment breach. So my 2D model, if I will just quickly hide these files. In my 2D model, I have created an active area. So I just wanted to make sure that I cover the right floodplain of River Avon, and I'm also covering at least the pylon that I'm interested in, and a few of the remaining pylons on this floodplain. I have added a boundary. So this boundary is covering the estuary on the right floodplain. This boundary is an inflow boundary, so I can apply some tidal data. This can be either some observed tidal data. So if you have some really high events or high tidal data that you manage to get, or you can use tidal data which is a derived data 100, 1,000 years return period, and apply it in your model. And I have also added a breach polyline. So through this polyline, I have actually lowered the FabDem data. So I think in this example, I lowered by 5 meters. And in here, if I will look at the Fathom data, the terrain shows that it's quite high, so it has captured the linear defense, which I have in here, but I chose to lower it just for this breach analysis. I created a 2D simulation file where I have added the Fathom 10 meters FabDem data. I have added my breach scenario. So these are the polyline and the points. I've selected the grid size, the time step, and I have also added the boundary condition. So I've added my shapefile and an IED. This is an event file where I have added my my tidal data. I have run this scenario and I got some model results. So I can then look at velocity data and water depth. So if I will zoom in, I can see that this pylon is affected by this breach. The results will allow me to do a further assessment of potential scouring where the T-pylon has been installed. You could also, in this model, you could also reinforce your embankment. So instead of relying on the terrain data, you can create a shapefile in Flood Modeler, and you can add the elevations of the AIMS data, of the flood defense data. And then you can use these results to further your assessment. So Fathom data offers a robust foundation for initial flood risk assessment. It has quite a wide range of detailed insight, which is readily available. And depending on the project objectives, further in-depth analysis can be pursued. And importantly, the same Fathom datasets remain fully applicable and valuable throughout more advanced stages of the modeling. So if you allow me to go back to the presentation. We will have another poll. So this time it will be related to the Flood Modeler software, where we would like you to tell us what Fathom features would you like Flood Modeler to focus on for development. Also, the full data is available via the Fathom global website under the Fathom Jacobs license. And I am happy to let you know that Fathom sample data for the Upton upon Severn will be available in Flood Modeler version 8. So that will either be available through the software, or in the knowledge base, we'll have a page dedicated to Fathom where you can access this sample data. And we have chosen Upton upon Severn because we have quite a lot of example exercises for hydraulic modeling focused on this area. So we thought it will be most beneficial for you as users to have a look at the Fathom data in this area. Gavin?
Wonderful. Thank you, Cristina. Thank you for doing a live demo. It's always nervous when you're doing that on these types of webinars. So what we'd like to do now is just a bit of a wrap up. So the data sets that are available in Flood Modeler are our flood maps for UK, US, Japan, and globally. And that's for the current climate state, but also under future climate scenarios. That can all be selected, as Cristina showed, through the interface within Flood Modeler. Also, the risk scores and the global terrain data is available as well. And in version 8, we're talking about we are making available the metadata, so you get that confidence index. And one of the other data sets that we didn't manage to cover today, we provide effectively our DEM for the flood modeling. What that allows you to do is actually take our flood depth with a water surface elevation data set, is actually calculate the relevant depth of inundation for the asset you're working with. So that could be a road or a railway, and you might want to calculate the specific depth of inundation. So that gives you a flavour of the data sets that are available. Let's just go through to the next slide, please, Cristina.
Sure.
We've got a number of actions now that you can go forward with. We're making available the sample Fathom data for Upton on Severn, as Cristina mentioned. That's going to be available in Flood Modeler, so I would encourage you to have a look at that data. We are doing a more detailed presentation at the Flood Modeler Conference in Leeds on the 8th and 9th of October. And we've got a workshop there with one of our flood modelers working with Cristina to go through a much more detailed scenario and case study. So I'd encourage you, if you haven't registered for the conference, please do. We were there last year, a really great conference, lots of great dialogue and knowledge sharing. And it's brilliant to sort of get the flood modeling community together and champion the good stuff that everyone's doing. So if you're not going, I really would encourage you to sign up to that. We can give you access to sample data that we can provide to use in Flood Modeler. If you're interested in doing that, then please drop us a message in the Q&A panel with your details, or you'll see my email address after this. Drop me a quick email. Okay, so we're going to jump to some of the questions now. If we go to the next slide, we've had quite a few questions, so thank you for those. Firstly, one of the questions was, for climate scenarios, are you using CMIP 6 or older? Okay, well, that's an interesting question, because we use both CMIP 5 and CMIP 6 for a variety of technical reasons. So we use CMIP 5 for the fluvial modelling and CMIP 6 for the pluvial and the coastal modelling. Okay, and we use effectively a change factor methodology to determine the difference between current climate scenarios and calculating future scenarios. All that methodology is available in the papers that we have published on our website. One of the other questions I've got is, we already license Jacob's Flood Modeler. How can we get access to the Fathom data? Okay. What are the ways of doing that? So if you work for organizations, so Arrow, Mark McDonald, and WSP and Ramboll, we already have global license agreements in place with those organizations, which means that you can access the data within Flood Modeler already. All the license and paperwork's taken care of. You can actually get an assessment of the cost within the Flood Modeler interface that we provide before you start drawing down the data. So you can access that. If you still want to access the data and you're a different organization, whether that's a commercial or a government organization, then we can just put a standard data license in place to allow you to access the data. So if that's of interest, again, please, my email's here, just drop us a note and we can follow up on that. The other question related to that is looking at what data sets are available. Well, we've given a flavour of that. It's the flood maps, risk scores, and the terrain data available now. So there's quite a lot of data available. I think we've gone through stuff very quickly today, but there is a lot more reading, a lot more material we can share with people if they want to dive into more detail. So I've got a question here around assessment for single dwelling under planning applications. Is the software overcomplicated for flood risk assessment? I would say that it kind of depends if you're looking at a single site or you're looking at a larger development. Obviously the EA data will give you for regulatory purposes would give you a good understanding, but some places that don't necessarily have Environment Agency coverage, excuse me, in England, but of course, or Wales or Scotland for SEPA and NLW respectively, then filling in the gaps with Fathom data would potentially work. Okay, I've got another question here talking about what is the difference between the existing FabDem data and the new FathomDem data. So there's quite a lot of difference between the two. They use quite a different methodology in taking the base TandemX data set and deriving the outputs. We've published papers on both data sets that go into the methodology, so I'd suggest having a look at that. But essentially, as an end user, you can get a much greater fidelity and granularity in the Fathom DEM data set compared to FabDem. But having said that, of course, FabDem is a real step change on beyond the standard global terrain data sets that are available. If you're from an academic research perspective, you can access the sample data through the Bristol University website. For any commercial application, then that would need to come through Fathom for licensing. But again, we can provide sample data if people need. I'm just conscious of the time. We're getting to the end. Cristina, I don't know if you've got any couple of words of wisdom just to wrap up with.
Thank you. I think I have answered a few of your questions in the Q&A, and I hope they have been helpful. If you would like to have an experience of flood modeler and try to play with some Fathom data, please do get in touch with the flood modeler team, and we will also support you on having a really good experience in model build or analyzing the Fathom data.
Great, thank you. And I'd just like to thank you all for joining us today. I hope you found it useful. This session is being recorded, so if you'd like to share any of it with your colleagues or friends, then please do so. There'll be a couple of follow-up emails coming up. And for those of you who are going to be in Leeds next month, we're really looking forward to meeting you and discussing our data and, of course, the Flood Modeler platform. So thank you very much for your time. Have a good rest of the day. Goodbye.
Thank you. Goodbye.